welcome everyone. Like Sandra said, my name is Natan Silnitsky, and I'm a backend infrastructure developer at Wix.com. And I'm part of the data streams team at Wix that is in charge of all the event-driven infrastructure for our microservices system. And we have been using ZIO in production for the last year and have gained a lot of knowledge about how to incorporate it for new code, for legacy services. So I thought it would be a great opportunity to share with you the lessons that we've learned. A few words about Wix. So Wix is a website building platform that allows you to manage your online presence. We have 190 million registered users from 190 countries, and 5% of all internet websites run on Wix. Sorry. So specifically, data streams team at Wix, like I said, we develop event-driven infrastructure, and the event-driven system produces 1.5 billion Kafka messages per day and more. 900 developers use our infrastructure in their code, and 1,500 microservices use our Kafka SDK wrapper infrastructure called Greyhound. Greyhound is our Kafka SDK wrapper, where we wrap both Kafka producer and consumer. And the idea is to offer simplified APIs and very cool additional features for our developers to use, including all kinds of retry mechanisms and powerful parallel execution of consumer handlers. And also it adds a layer of abstraction that makes it easy to change stuff behind the scenes for everyone and have it in their services immediately. And we recently rewrote it in Scala ZIO and also open sourced it. So we're very excited about that. Now, our team's code before ZIO, basically we're talking about SDK libraries like Greyhound and a gRPC proxy services for other non-JVM languages to use, and infrastructure services like replication, monitoring, and also a Kafka control plane that we built from scratch to fit our needs. So a lot of code that is part of our team. And it's a mixture of synchronous code and future-based code, meaning that there is a lot of eagerly evaluated code that it's hard to actually control the synchronization and timing. A lot of threads are used, especially in Greyhound. And so we needed to use a lot of Java synchronization primitives in order to avoid race conditions. So a lot of brittleness and a lot of boilerplate. So what ZIO gave us is, I'll just enumerate a few benefits. Lightweight fibers instead of threads, so that's much cheaper resource usage. And a lot of great parallelism and concurrency operators in ZIO. For instance, to constrain the level of parallelism, you get collect all power n. And no implicit execution context that we needed to thread around in all our future-based code. Easy retries, so we get retries with powerful scheduling setup. Better error handling. So when we moved to ZIO, we gained a lot of confidence that we can control exactly how errors are propagated, where to catch them, and know that nothing was going to fall below the cracks, and a lot of flexibility in error handling as well. And the classic gain of functional programming, lazy evaluation, and referential transparency, meaning that it's really easy to refactor stuff and not worry about behavior change. And local reasoning, so you can look at a method's code and know exactly what it does without needing to look at the context, what happens before or after. So when we want to migrate our code to ZIO, we thought about how to do that. We have a lot of code base. So it's not like the goal is, oh, I want to get immediately to all of the service code to be wrapped in functional effects and have the runtime at the end of the world execute the ZIO descriptions and have a great functional service. That will probably not be realistic for your legacy service that has a lot of edge cases. So a better approach will be to gradually wrap your code with ZIO effects chunk by chunk. So here we have an application where like standard microservices, and we have a framework probably like Play or Akka that will handle our incoming requests for HTTP, RPC, or also maybe Kafka consumers. And you have your internal logic. And then you have probably third-party calls you do for external services, HTTP, maybe you call database and query it or produce to Kafka. Now, how do we approach migrating code here to ZIO? So the first step, the easy step, is to actually migrate your pure logic code that is not affected by frameworks or libraries that you use. So let's see a quick demo of how to do that in a sample application. So here we have our easy to understand gRPC service. It's an order service, e-commerce service that handles errors, creates them, and retrieves them. So basic CRUD application. Here we can see the definition in protobuf, and then the protobuf library Scala PB generates the Scala code. So if we look at the order servers, there is like boilerplate here to set up and bind the different gRPC methods. But the heart of the code lies here. So here is where we implement the endpoints and provide our own custom logic. In our case, in this example, we just call the database layer to create the order and get it. And the database layer here, the interface is with future-based interface. It could have been also returning synchronous code. And it's quite simple and straightforward here. So I think the easiest place to start is your internal logic that actually handles the incoming request. So in my case, it's going to be very simple because we're just going to change basically a few lines of code. So here, create order returns the future. So if you want to convert it to ZIO without doing anything too big, then just use the ZIO from future operator. And then we'll get back the order ID with the ZIO wrapper. Now the gRPC endpoint actually returns a future. So we need to convert it back to a future. So we're going to run the runtime execution of ZIO in order to get back the future. So basically, we're doing a very mechanical operation here, switching to future and then back to ZIO and then back to future. So it's quite straightforward, but it gives you a place to start and put ZIO code in your legacy service. And I'm doing exactly the same thing for the other method. And let's see if the application still works. Of course, this is pretty much a toy example, but you can think that there are going to be a lot of methods that you need to do it over. And then this helper can come in handy where you just wrap your ZIO code and bring back a future. Okay, so looks like the service has started. And now we're going to call create order. Great, so we get the order ID back. That's fantastic. And now let's see if we can get the order back from the ID. Yes, indeed. The service is running, it's retrieved the order, everything looks great. Then what if we want to introduce some brand new ZIO code? For instance, I wrote here a cache that implemented in ZIO that will allow us not to go to the database layer each time, to skip that in order to gain performance. So you can see here that the interface returns ZIO values. Actually, task is a ZIO that has a throwable error type and simply has a reference, a ZIO ref that has the ability to provides state, immutable state in sort of a functional effect style, similar to atomic reference, but in functional style. And we'll just update the ref with the update to the map and retrieve from the map what we need. Very straightforward, and clean up that I didn't implement in order to have like TTL or remove stale orders from the cache. Okay, so how can we actually use it? So when we make the Z order cache, we actually, when we make it, we actually return a ZIO type here, or UIO in this case. So when we create the cache, we actually return a ZIO. So we have to wrap everything inside a for comprehension. And then in order to run it, because we're in the application level, we're going to use runtime unsafe run. So let's put everything into the for comprehension, and we'll yield and close this. So you can see that I'm not focusing on wrapping all of the expressions in ZIO yet. I just want to see that everything works accordingly to the change I did. So let's see if we still compile and run. I'll just format the code a little bit. Great, so looks like we're running. That's awesome. Let's see if the cache is utilized. Oh, well, actually, I need to use the cache, right? So let's provide the cache to the order server and actually use it. That will be good, right? To actually use the cache. So here I want to use the cache when I create the order. So it's be like a write-through cache. So we create the order, retrieve it back from the database and put it into the cache. Good. And so this is future return converted to ZIO, but this is already pure ZIO, and it interrupts very nicely and works well together. And now I'll change the get order implementation. So we just want to retrieve the order from the cache, maybe. It returns an option, and then fold on the option. So if it's not found, then we'll go and call the database. But if it is found, we'll print to the standard output and wrap the actual value of the order in ZIO and return it back, and then convert it again to future, because the gRPC method is future-based. So now that we have all the code in place, let's actually compile and run it and see if it we actually can use the cache. So we have a ZIO cache where all of the rest of the code is actually future-based. Okay, so I'm going to create the order and then use the new order ID, get order. So we call the gRPC service and we get the order back. And yeah, it's found in the cache. Great. So we introduced completely brand new ZIO code into our legacy service. Okay, so the second step that I recommend when you migrate your legacy service to ZIO is to actually go and check out your third-party libraries that you use. You may want to switch them over to ZIO-flavored libraries. There are many out there for HTTP and databases, and also Kafka, like you saw with Greyhound. And but if you don't have such a thing, then you can just wrap your existing future synchronous API with the ZIO flavored API in order to reduce the boilerplate on the call sites in your pure logic part of your application. So let's see a quick demo of how to do that. So I'm going to show you the exact same application. By the way, here now I wrapped the synchronous effects with nice ZIO effects, and also the blocking one with effect blocking. So it means that the execution here will be more healthy because everything will be controlled by the ZIO runtime. And you remember that our database layer is the API has feature base. So in order to just wrap it with ZIO, it's really easy. So I just create the exact same interface, but return ZIO task in this case. And then I just delegate the request from ZIO to future. So now we have a nice Z in-memory order DAO. So let's use it. So we'll put it as a collaborator for our order service service. By the way, I'm using a constructor injection here. I'm not using ZIO environment yet because with legacy service, that's going to probably be more tricky part because of a lot of code for composition of your objects. So I would postpone ZIO environment to a much later stage. Okay, so now we will use the Z order DAO interface, and we'll get compiler hints where we no longer need to convert future to ZIO because it's already ZIO based. And that's great. We're actually removing boilerplate from the call sites and making our code look much better. Great. So let's run and see if everything is still okay and working. So imagine it can be in a lot of places. So doing this find and replace stuff will be great. So let's create the order and get it back. Get order with the new order ID, and we get it back. Great. And we probably even found it in the cache. Excellent. So we saw a very quick demo of how it's really easy to push the ugly non-ZIO code down so we get as much healthy, nice call sites that use ZIO. And the third step here, that's the last one I'll show you today because we're really short in time, is to actually switch over frameworks that you use to ZIO-based solution. Because non-ZIO code. So it's probably will take a bit more effort. That's why I put it only as step number 3. And we'll see a demo of how to change our RPC endpoints from future-based to ZIO-based. Okay, so that's talking about the third demo. And so if you want to switch Scala PB to work with ZIO flavor, then we need to add this SBT plugin for ZIO gRPC. And also ZIO gRPC gives this great wrapper for a ZIO application, meaning that now we can actually run all of our code as ZIO and have the runtime execution of ZIO is actually hidden from us. And all we need to do is actually specify the port that the gRPC will listen to and the actual service. So we want to get a ZIO-based service, but now our order service actually implements a future-based one. So let's change it to ZIO. So we have here our future implementation, and we're going to change it to ZIO. So it's no longer private. We're actually going to use this as the only implementation here. Let's call it Z order implementation. And I switched over to the ZIO Scala code that was generated by Scala PB. So now everything's going to be ZIO. That's great. So we no longer need execution context. Yay. And our create order code does no longer need to actually run the ZIO code and provide the future. That's no longer necessary. One thing that gRPC does require from us is to catch all the exceptions and convert them to a gRPC status result. So that's what we'll do here. We'll get and catch all the exceptions, And we know that with ZIO, we will definitely catch all exceptions here, not like with Future that some exceptions are not caught. And the compiler screams that we need to provide collaborators, and that's exactly what we'll do. And let's quickly do the same thing for get order. So this no longer returns a Future, it actually is going to return ZIO. We no longer need the runtime execution here. And we also need to do the conversion from exception to gRPC status, like you see here. The error type is status. Great, so now we can actually use Z order implementation in our main server, main application. So we don't need the execution context anymore. And we don't need to convert to run the runtime here as well, because the ZIO gRPC server main is going to do that for us. And look how much boilerplate we can remove by using server main. That's fantastic. And all I need to do is actually specify a value, a ZIO value for the server, actually return it in yield. And I think that's it. Look how nicer the code now looks. We use a cache. We actually call a schedule to clean it up in a different fiber with a fork and spin up the service, the gRPC service, in a complete ZIO flavor. And almost everything now looks here like ZIO because we pushed the non-ZIO API down, like in the database. So our code looks more and more functional and composable, and that's fantastic. So let's just see that everything still works, that I'm not actually fooling you, that we do have a gRPC ZIO flavored service. So the service is running, and we'll call create order. And so it already looks very promising. We'll just finish it with get order. Yeah, so we successfully managed to migrate. That's great. Cool. So to summarize, write all new code that you have in your legacy service in ZIO. Don't be afraid of it. Even if you're just introducing a small new class like we did with the cache, because you can easily interrupt that pure ZIO in your non-ZIO environment by using the from future or executing runtime. Don't be afraid of having multiple runtime executions in your code, as long as they are all the same runtime. You won't have trouble with the ZIO ref and other immutable state. As long as you have everything in the same runtime, you're good. Migrate old code gradually when you have time. It's not that urgent to do. You know, like you're touching some file, do it then. And when you have enough time to do technical debt work, then just switch your legacy libraries and frameworks to ZIO-based ones, so you get the complete ZIO picture. And I would postpone changing your construction-based injection or Spring Beans to ZIO environment to a later stage. And enjoy writing in ZIO. It's so much fun for us to work like that. It gives us much more confidence in the code rewriting. So all the examples I showed today, and a lot of other examples that I don't have time to cover in this talk, you can find them on this link at this repository in GitHub. And also Greyhound, like I said, is open source, so you can check it out. It has a lot of cool features if you're using Kafka. This is the link. And so thank you very much. And you can find out all the slides and links I put on the slides in SlideShare on this link. You can follow me on Medium and Twitter to get all the latest updates on what we do with Scala, with ZIO, with our event-driven design, architecture, everything around Kafka. That's what I write about. And you can also check out my website at natansil.com for previous talks I gave in conferences, videos of that.